So hi guys, my name is Rahul Inchal and today we are going to solve time series analysis for stock prediction for the data of Bharathi Airtel. And so let's not waste much of our time. Let's start understanding what I have done. This is a very simple time series analysis project, guys. So see now. So first things first, we will import packages. Fine, we are importing packages because it's textual data. And guys, I think you guys know about time series analysis. Time series analysis only happens for the one column where we have to find the hidden trends of the pattern and the patterns of the data, and then we have to predict. Now we don't predict very huge future, but then again we predict only very less, like 10-12 days of data. Okay, so next I have loaded my data set from the github. You can definitely see I have my github account over here, and if you go to my repository, that will be given in the link and the description link in the description as well. Time series analysis, if you see, I have not yet uploaded the ipynb file over here. I will upload it after I upload the video. So here you can see the CSV file I have. We have lots of columns. We are only worried about this one column called close price. And if you do stocks, you must be knowing about what do you mean by close price and all. Fine. So you hit raw onto this, and you have to copy the link over here, and that this is what I have done here. Okay. Now this is what it is. Now pass date is something, so Python has a, or rather pandas has a very good function called pass date, which means it detects the date and converted it into the understandable format. Okay, and the column is date. Fine. So this is my head, and I'm only worried about this close price. Fine. Now if I hit df info, now these are my infos, which gives me, fine, again I'm mentioning that we are only worried about close price. Now let's see how close price is what. Now this is what it is. Now if you want to see Bharti Airtel, say BSC. Fine. So see, these are this is similar to the graph which we have, right? Yeah, this is a data from 4 June 2021 to it's a huge data set, I guess, which I have taken it from Kaggle, from, or rather this is from 2011 to 3 January. Yeah, 2011 to 2021. So this is the 10 years of data, right? This is the 10 years of data which we are going to analyze. Fine. So this is my info, and so this is a 10 years of data. It started from somewhere 350, now it is around like 550 or something like that. Fine. So yeah, now as I'm only worried about one column, that close price, so I will separately create a data frame Airtel close, and store a data close price onto that. Fine. So I want to convert it into data frame, and I want to drop the column called date. Fine, because I'm only worried about, in time series analysis, guys, it's a subset of, you can say it's a subset of deep learning. In time series analysis, we are only worried about a single column, and based on the hidden trends and patterns, we predict the future. Fine. So I have dropped the column as well, or I've dropped the column of date. Fine. So now you can see, now this is the index which will be there. You don't have to worry about this because we only have one column right now. Fine. If you see the shape, we have 2582. If you see 2582 divided by, say, something 365, right? 365. So you see 7 years, because what happens is BSC is stock exchange is closed on Saturdays and Sundays and holidays and all. So if you take out all those, you will be left with only 7 years of data. Fine, but even 7 years of data is huge for us. Okay, so this is run. Okay, so I am converting it into data frame, the Airtel close data frame. Fine. So now before going further, now we don't have any null data, or we don't have to transform any data. Transformation we'll do in minmax scaler, but we don't have to do any exploratory data analysis, any sort of that. Okay, no feature engineering also, because there is only one column. So train data. So see what happens is, in time series analysis, we don't predict huge, say for example, I have 2582 days of data, and I won't be predicting 1000 next 1000 days of data, because what happens is, in deep learning, or in a sequential model, what in time series analysis, what happens is, every next prediction also comes with the noise. So next to next prediction will be predicted on the basis of the past data. Say for example, if I'm predicting tomorrow's data, Okay, so today the tomorrow's data will be predicted with including the noise for today as well. And day after tomorrow's data, if I have to predict, then tomorrow's noise will also be taken into accumulation, and then day after tomorrow's noise is being predicted. So what happens is, if you predict too long, so many of the days, then what happens is that noise piles up together and it will start giving you very inaccurate results, which we don't want. Of course, that is the drawback of time series analysis. But then again, we are not worried about like next 50 days, we are only worried about next 10-12 days. So that's why what I have given is, I am taking train as 2570, and I am only predicting next 12 data. So if you see, what is my 2582, right? 2582 minus 2570. So you will see I'm only predicting next 12 days of data, right? So next 12 days of data. So train from 0 to 2570, and from test from 2570 to last. Fine. So this is what I am giving for my test and train. Now again, this is your personal choice. If you want to scale it, I personally tend to scale it. And also I tend to scale it from min max scaler, because it gives me a range from 0 to 1. It's all positives, and also the values are scaled, so that values are scaled, the machine will process it in a very efficient manner in comparison when you don't scale it. Fine. So scaled rate data, I have trained data, I have fit and transform, and test data I have transformed. I hope that you guys know about machine learning. In machine learning, we have studied about why do we okay, I have not run this. I have to run this now. Yeah. So okay, I did not run this also. Yeah. Okay. Yeah. So yeah, now this is all done. Now we'll go for time series analysis. Okay. Now from TensorFlow Keras, I will import time series generator. Fine. So I have imported that, and then now we'll start creating a model. Now let's see before that what is the test shape of it. We know that 12 column which we are predicting, and I have my train, that is 2570. Fine. So I will create a variable called generator, in which I will be giving my hyperparameters, like length is equals to 12. Length is equals to 12. Dilemma or normal thing to give length as a 12, as the same number what we are predicting. And the batch size, because I don't want to send my entire data for once. So if I give my batch size as 1, then the entire data is being taken into consideration for prediction. So if I give batch size of 32, then the data is converted into 32 batches, and then everything is every single batch is being used for the prediction. Fine. So that's why this is what it is. Now we have started, like we will start importing our normal or our deep learning models. Fine. So from TensorFlow Keras, this is a sequential model. Okay. And for the layers, I am adding dense layer, simple RNN layer, long short term memory, LSTM, and dropout. Fine. So n feature, I will keep it as 1, because I only have one output, right? So yeah. So now these are my hidden layers. These are my sequential layer, in which I am adding simple RNN, dropout rate 0.2. I don't want it to learn from the entire previous data. I want it to forget some of the data in between. That's why I've given, this is a hyperparameter tuning, guys. I got my best result from these tuning. You can hit and try with the datas. Okay. Now I've added one dense layer. You can add two dense layer as well. And for the optimizer, I have added Adam, and a loss I'm measuring it from MSc. You must be knowing about from the machine learning. Now let's see about summary. What is the summary of it? So I have 1088 parameters. Okay, for simple RNN. Fine. And this is a summary which you can definitely see. Now let's fit our model, and I don't want to give epochs. Now fit our model and give an epoch of 10. Okay. And I don't want to shuffle my data. Of course, this is a very basic question. Why do I don't want to shuffle my data? Because it's a sequential model. It's not a normal machine learning where you shuffle the data. I don't want to shuffle my data, because I am finding the trend, I am finding the pattern. If you shuffle the data, the pattern will be lost, and then the entire hard work will go in vain. So I will start. Also you can use a callback function for it, because if you don't want to, if you don't want to run your epoch 10 times or 100 times, or whatever epoch you want to give, you can also use callback function, where what does it do is, it will stop the epoch running when the error rate is stabilized. or if the error rate is stabilized, or if you give a value of say patience as 3, so it will with the three losses, if they have same values, then it will stop over there. So but it's a textual data, my model, and the data I don't have huge data, so that callback function from the keras is used only used for those where the data is huge, and at that time you cannot run each, you don't want to run each epochs unnecessarily. So at that time callback function is used. I have not used it because even if I give it 30 epochs, say for example, it will run very smoothly. Fine. So okay, so I got my I've trained my model. Okay, let's see how many losses. Let's plot the loss function. Okay, so from the history, so I'm plotting the losses plot. So see, after the first epoch, it has gradually decreased. The loss function has gradually decreased, and it has hit the threshold over here after eighth epoch. Fine. So this is where loss function comes into play, or rather callback function comes into play. After this, or say maybe this, it will stop doing the epoch because the model has hit the threshold. Now after this, the loss is not going to be minimized. If you forcefully increase the epochs, then there is a huge chance of overfitting your model. So let's now evaluate our test model. Okay, so now I have reshaped it as well. Okay, I have reshaped it for the things which I want, and then I will predict my first eval batch. Okay, now first eval batch is what did I get? 0.278199. 0.24 was the original one, and I predicted 0.27. So see, now what do I want? I have predicted only one, but I want to predict for the entire. So for that I have given this. Okay, I have initiated one test prediction as 0, or empty list, and then after that I've started. Now this for loop is very simple for you to understand. You can definitely understand that. Okay, and after running these iterations, I will print my test prediction over here. So if you see, so I have my test prediction 0.27, 0.28, 0.29. So if you count this, these are 12 predictions which I have made. That is what my test size was also. Okay, so now I have scaled my data, right? I have scaled my data, but I don't want the scaled data. So I have to do inverse transform to get the original price of the close price of the data. So I will do the inverse transform over here. So I got the again 12 values. Okay, so now I will for better visualization, let's create two more columns. Two more columns is from predicted values. I already had one close values, and also let's do the difference that is close. You will understand by this better. Okay, yeah, see now this is the original cross price, this is my prediction, and these are my difference. See, there are very less difference. If you see, if you want to visualize it with plots, let's plot this as well. So see, this is my data from the entire 10 years. Okay, or 7 years, if you whatever you want to say. Okay, and these are my prediction of the 12 which I have predicted. And this, so there are no labels, right? Let's print once more test dot plot. Yeah, see, now what do you see is blue color is my close price, the original price. Orange color is my predicted price, and this is the difference. You don't worry about this. This is just this is just happening because there's in the data frame it is also there. So don't worry about the difference. But this is, see, I'm very much happy with my model. Definitely it is predicting very good. Okay, so with this is a very basic model which I have tried to do for the time series analysis. You can also go for LSTM model as well, because what does LSTM do is it tries to find the patterns, and then it tries to replicate the pattern what is happening in the prediction as well. Okay, so yeah, this was it about the time series analysis for stock prediction. My name is Rahul. Thank you for watching. I'll meet you in the next video. Till then, take care. Bye bye.